Hello, everybody. Good day. Hope everybody's having a great day. Today, we're going to talk about bulk ingredients and how they relate to managing your combustible dusts and the things that you need to do. There's some requirements, some things you just need to do to protect your business. This is kind of an encore performance of a presentation I made to the American Bakers Association about 3 weeks ago in October. And so you're going to see it's kind of slightly, leans towards addressing the baking industry, but really all of the concepts I'll be talking about are really transferable to anyone who is managing or handling any type of bulk ingredients, whether you're receiving them and you're moving them from one part of your plant to another. It's really going to apply to everybody. But again, you're going to pick up on that slant kind of towards the baking industry. So let's first start off about understanding your bulk ingredients. So, again, looking at the baking side, there's certainly other type of products that can create dust, but the food industry, you're handling sugars, you're handling cocoa beans that get ground up, you make powdered sugar, you got different types of wheat berries, corn, starches, anything like that you're moving through your system through mechanical means, you can be producing dust as a result. And again, so you're handling your bulk ingredients. There's a number of ways to handle it. So as I mentioned, first off, there are storage opportunities. So if you're receiving a bulk ingredient, you're typically bringing in either a truck or a rail car, and you're putting it into some type of an inventory situation, whether it be a silo, totes, other big silos, smaller silos, internal silos, that type of thing. But you've got a handling vessel that you're receiving it in from a supplier. So then inside your system, then you're handling these bulk ingredients or transferring them, different processes. You're talking open belts, you're talking screw conveyors, you're talking pneumatic systems. A lot of people are using bucket elevators, as we see here. All of these processes are moving that material probably from your storage to some other part of your operation where it will be further processed or mixed in as an ingredient. So wherever you're moving these products, you have an opportunity to create dust. So as a result, you have spills and cleanups to do. It could be something minor, as we see here in the center, where there's basically a slow buildup of a product in a room where you're doing all your transferring. You can have some major spills, as we see here, and hopefully everybody doesn't have a major spill that requires this type of operation. Now you're talking more than just a spill or a cleanup. You're talking a real mess. So let's first talk about handling those bulk ingredients and the spills and cleanup. So some tips for maintaining a clean and safe environment. And a lot of this is going to seem, really common sense, but it's really good to go over that too. So it's clear in our minds. One of the first things we want to do is when we're dealing with combustible dust, it's about keeping things as clean as we can. We know through operations things are going to happen, and we're going to talk a little bit more about that as we go forward. But to start off with, let's make sure we have proper ventilation of storage systems and transfer systems. We need a routine maintenance of dust collector systems. I've seen issues in plants where people didn't check their dust collector systems certain times of the year. For instance, you have a high humidity area, time of the year, June, July, August, dust collector systems plug up. People are thinking their dust system is working, and when in fact they get ghosted over with films and they're not doing its job, and you end up creating a situation with dust inside of systems. That could be a problem. You want to clean up spills immediately. Again, it's something that's hard to do sometimes when we're working operations, but we really need to keep up to date on cleaning up spills. Routine cleaning of overhead dust accumulations. And we're going to talk a lot more about this. This is a very extremely important concept, again, that we're going to explore a little bit further into the presentation here on why that's so important. Maintain and enforce a well-communicated expectation level of cleanliness to your employees. If you don't make it important to them, it's not going to be important. So you have to make sure that you communicate that well and explain exactly how you need to be cleaning, why you need to be cleaning. So, and that includes the training and education of employees of proper cleaning methods. Not only the methods, but the tools in which they use can have an impact on combustible dust. You want preventative maintenance programs to address ingredient leaks throughout the process. I don't know how many times I've gone through silo rooms where you walk in and you can taste the sugar. You can taste the flour in your mouth just walking in because there's so much dust in the room because we've got a lot of these pipes that are leaking. And you know what? Fine, we've cleaned them up when it happens, but it takes a week to clean them up. And not only are you losing money on the floor that you're sweeping up and throwing away, but you're creating a situation whereby you might have a combustible dust situation. And so you want to include a routine review of your bulk handling systems, everything that you're moving your bulk ingredients with in your weekly or monthly self-inspections you're doing. So again, I mentioned proper cleaning methods. You want proper ventilation of the areas, as I mentioned. You want to provide the required personal protection equipment to employees. You want to employ as much dry cleaning methods as possible, but you want to use properly rated vacuum systems or central vac systems. I don't know how many times I've walked into a room where there's dust everywhere and someone's got a wet dry vac or just plugged into a socket in the wall that's not a protected socket type system, which can create a spark. Make sure your equipment is properly rated for high dust situations. You want to do a lot of hand cleaning. You want to do sweeping. The biggest point I want everybody to take away from here is stay away from the much used system that we've used for many years of cleaning up dust with compressed air cleaning. Again, it's not only a personal safety issue from an OSHA standpoint and from an employee safety standpoint, but you want to minimize your dust dispersion, again, which we're going to talk a lot about when we move forward here into the combustible dust portion of this presentation. But stay away from cleaning with compressed air. Use all of these other methods if possible. Again, training and education of employees of proper cleaning methods. Never use compressed air. Capital letters. Everybody remember that. That's the test at the end of the presentation, the only test question. So a lot of it has to do with building design. How have we designed our processes, our buildings, to help facilitate the minimizing of accumulation of dusts that can lead to combustible dust situations? So again, look at your structures, look at your ledges, equipment, your piping, your conduits, a lot of overhead stuff, your ceiling supports and your lights. Great areas, especially horizontal surfaces that allow an accumulation of dust. And particularly, those are probably the last areas that get cleaned in a plant because you have to get a ladder, you have to get a scaffold, you got to maybe stop the operations to get there. It's one of the most neglected places in your system that gets cleaned. So if you're in a position to be able to design a new area, a new building, whatever, think about those surfaces that could collect dust that's through your process. So let's talk about managing your dust. So there's 5 elements when we start talking about a combustible dust event. So those of us who may remember our high school chemistry or science classes, they always used to say, well, there's 3 elements that are required to create fire. It was the classic, it was oxygen, you needed an ignition source, and you needed fuel. And those 3 things allowed a fire to happen. Now, with the combustible dust, there are 2 other very important components, and all 5 of these, or the pentagon of a combustible dust event, include, again, the oxygen, an ignition source, a fuel, confinement, and dispersion. So we'll talk about that. So combustible dust, again, the elements, first step, you want to identify, this is your fuel. Identify all ingredients that compose a combustible dust explosion threat and may determine each of their attributes to determine the probability of required concentrations for explosion. So a lot of people ask, well, where do I find out if this product can pose itself as a combustible dust? First place to go to is your SDSs. It'll have all of the combustible dust type data on there that will tell you what concentration levels, how combustible it is. It'll have all of those elements. So your very first step is take a look at your operation. Am I producing or receiving product in, or am I through the process of my working these materials, am I creating a situation where I'm creating dust from that ingredient I'm using that could cause a dust explosion? So again, I'm not going to go through all of these, but these are some of the type of things that you're going to see on your SSDSs, your explosion severity, maximum pressure, a number of different elements that will tell you what are the situations that would occur that for that particular product or ingredient that will make that ingredient be ready to be combustible. So let's talk about some legislation. So without going through all of the laws, all the things that brought us up today, let's talk a little history to bring us up to date where we are. So in the past, OSHA has been kind of the ruler over the dust explosion type of thing. And they really haven't had a particular dust or combustible dust standard. What they've applied is this big giant catch-all general industry standard. So it's applied as an umbrella standard to industries as a basis for inspecting and citing for combustible dust hazard situations. Previously, it was mainly applied in the grain industry, woodworking, and metal. It really wasn't applied so much to the food industry. Those of us who may remember earlier in our careers, when you ever heard about something blowing up or something even related to food, it was always a grain elevator that blew up. And we're going to talk about sugar here in a minute, which really kind of changed the landscape. But really, everything in the past has been, OSHA's used this standard as kind of a catch-all to say, you have too much dust on the floor, you have too much dust in your area. It's their general industry standard, but no specific standard. But on February 7th, 2008, again, there was one particular event that, as I say, changed the entire landscape for the country. What happened was at the Imperial sugar plant in Wentworth, Georgia, there was multiple explosions and fires at a sugar refinery. And people said, what? Sugar explodes? Sugar is a fantastic source for an explosion given the right conditions, and we're going to see some of those. So in addition to the massive destruction to the property, I mean, it literally went off like a bomb and blew up. You know, there were 14 people unfortunately killed and 36 maimed and injured in that situation. So I'm going to play for you a little snippet here from off the internet that basically described what happened at the Imperial plant. The surfaces were not cleaned off enough, so they started to accumulate sugar, through air compression in the tunnel beneath the sugar silo. The sugar flowed through the chutes onto this open conveyor belt. From time to time, the sugar would get stuck in the chutes. It would overflow the belt and start falling on the floor and falling on the equipment. The tunnel, in this case, though, the way it's set up now, the tunnel was large and it's basically ventilated. It kind of cut down on a concentration factor. But in order to try to contain the dust, the company decided to cover up the tunnel and then close the tunnel. However, they didn't install a dust collector system. So now all of that sugar dust that was open to the atmosphere was now contained inside that conveyor belt. So as we see, there was a pile up, there was a jam up of sugar that started to pile up. So dust likely built up to an explosive concentration. About 7:15 p.m., the sugar dust contacted an ignition source, most likely a hot bearing, and an explosion occurred. Had all of those 5 elements. As you can see, the resulting explosions. So as a result, that resulted in a chain reaction of secondary, tertiary explosions. All that sugar on the floor, the building collapsed, the floors collapsed, adding more sugar dust and trapping employees. All the interior lighting was cut. Exit routes out of the area were on a block because of the explosion. Here you see an actual explosion as it happened that evening. That's from sugar dust, folks, blowing up. You had the initial reaction, and then you had the secondary, tertiary explosions that occurred. So as a result, it was very tragic, and it really shook and rocked the whole industry. OSHA really jumped on this. So it immediately prompted a call for new regulations. Well, as you're aware, the government just doesn't snap to and make regulations the next day type of thing. So they actually proposed a Combustible Dust Explosion and Fire Prevention Act back in 2008. So they kind of jumped on it pretty quick. It happened February 7th. Before 2008 was over, they had a proposal for a new bill, but it really never got anywhere. It never passed the U.S. Senate. So in 2009, OSHA began developing a federal standard for combustible dust. Congress then introduced a bill in 2013. So all this time, there really was no standard. And again, OSHA kept using that outdated umbrella standard to apply. So in the void of the OSHA not promulgating that standard for regulating combustible dust, again, as I mentioned, they continue to use a general industry standard. The problem was, and I've experienced this, we had people coming into our plants. I had a plant in Iowa where the Iowa OSHA people came in, and they were just hot on looking for all these problems. And we were a sugar company, and they were looking for it. The problem is with this general industry standard, there really was no training. It was inconsistent how it was applied. It was very frustrating for companies, frustrating for the auditors coming in. And so at that point, we still didn't have an OSHA standard. And they were starting to lean towards more of the National Fire Prevention Association for their leadership in the standard. So let's fast forward through a number of things that went on. So the NFPA actually put together a standard that was issued on September 7th, 2015, that had a compliance date that OSHA adopted as an OSHA rule under the general industry standard that had to be in place. All companies who were producing any type of a combustible dust had to have it in place by 2018, September, and it was called the Standard on the Fundamentals of Combustible Dust. Well, it established a relationship and a hierarchy between existing industry-specific combustion dust standards and ensures consistency, at least across the industry. Again, get away from that general industry standard. Now we were supposed to have a standard that applied to everybody, one size fits all. We're looking at combustibility as combustibility, no matter what industry was in. And what it did, it created a new type of way of looking at evaluating combustible dust, and it was called the dust hazard analysis rule. Well, what they found out was they really didn't promote this standard throughout the country. OSHA didn't, and found when it hit September that year that almost nobody had done anything about it. No one heard about it. They didn't advertise it enough. So what they do, they've actually deferred the standard, and they've made it much more public through a number of means. And like myself, I'm one of those means to get the word out to people that there's this new standard has been updated. It's called NFPA 61 or 652, kind of a compilation of the two. And the compliance date for this standard is now September 2020. So if you are a company that is handling any type of materials, again, whether it's food materials or any other type of non-food materials, that you're creating a dust whereby it could lend itself, given that pentagon of 5 particular attributes that can create a dust explosion, you are required to follow the rules that we're going to talk about here in a minute. It's now called the Standard for Prevention of Fires and Dust Explosions in Agricultural and Food Processing Facilities. So this new standard, this NFPA 652, has really been designed to target food facilities, agricultural facilities, because of the nature of, again, there's been other sugar explosions since that one in Port Wentworth, not as severe, but there are things going on. So the key to all of this, to get started, this big preventative piece that they've built into this, is a dust hazard analysis. So I want to talk a little bit about how do you create a dust hazard analysis and implement effective solutions. So we saw the explosion that caused a number of other explosions. I like showing this video, just a real quick video, not much to hear. It's more of a visual, but take a look at, it's not, again, a series of explosions, but a seemingly kind of innocent process. No one expected anything bad. You see the truck that's parked below, other equipment around, but just take a look at this. I thought this is pretty interesting. You can see that silo moving. It's breaking away. They're lifting it off. Very interesting. Who would have thought a corn silo coming down would be a source of a combustible dust? Again, that was fortunately was out in the open. You didn't have inside a building where it caused other things to happen. People were not close enough, but it's just that simple. It can happen. So what's a dust hazard analysis? So it's really similar to those of us who've done process hazard analysis. It's very similar to that process, but it's very specific to keeping your eye on looking at combustible dust hazards. So it's required, again, under this new regulation that's due for our compliance by 2020 September. It's required for all facilities that generate, process, handle, or store combustible particulate solids, including all grain elevators and corn milling plants. So again, if you're handling any type of product that is going to fall into this category, you are bound by law to be conducting a dust hazard analysis. So it's retroactive. You can't grandfather safety. You can't say, well, we've had this process in place, so we're not going to do anything about it. No, it's taking a look at your system and, again, analyzing where your problems are. And we're going to have a little more information here. So again, as I mentioned, the original compliance date was September 2018. They've extended it to 2020. So again, DH includes combustible dust data, as I mentioned earlier, getting the SDS and finding out all of that combustible data for the particular ingredients. So it's going to be different from corn, from sugar, from wheat, from metal dust, from wood, anything like that. So then next step is you want to identify potential areas of risk. Where is this product moving through your process whereby it could be a risk, it could happen, it could be subject to conditions that meet all 5 of these sides of this pentagon. You want to identify credible ignition sources and suspension mechanisms. Again, an ignition source could be a spark. It could be a hot bearing overheated. It could be metal scraping against metal in, say, in a bucket elevator. Then you want to identify the safe operating ranges. So again, so you have a situation, but is it contained? Like we saw in the video, have you built something around where you've contained that dust, and so you've increased or minimized the dispersion rate, so now you create a concentration. You may have a product that, yes, given the right conditions, it's a combustible dust, but if you take away one of these legs of this pentagon, you're not going to have an explosion. You look at your existing protection methods. What do you have in place to protect against that? Remember I mentioned earlier, number 1 is keep things clean, repair piping that has leaks in it. These are all mechanical, easy things that you can do that cost very little money to do that. Then beyond that, now you can only take that so far. If you still have a risk, now you're going to start looking at what can I do from an engineering perspective, mechanical perspective, to install explosion propagation methods. So either prevent an explosion from happening, which sometimes you can't occur that, but how do you contain that explosion so you don't have that situation like we saw in Port Wentworth at the sugar company there, where one explosion caused the next explosion, caused the next explosion. How do you contain it? And again, additional protection recommendations and an implementation plan. So again, so the steps in the DHA process, So you have to define the dust, quantity, type, and the characteristics we mentioned, outline the process hazards, conduct a DH review meeting after you've looked over your whole process. What have we found that we're at risk at? You want to prioritize hazards and create an implementation plan. And then, of course, implement that plan. Choose, design, and implement solutions. So as far as 2020 is concerned, you do not have to have everything done by 2020, but you have to have done your DHA and you have to have a documented plan. This is what we plan on doing. So basically, if OSHA walks in September, they're going to want to see your plan if you have combustible dust on your property, and they're going to know, what are you planning on? What are you doing about it? What's your thought process? What's your plan? You're going to need to be able to share that. So again, you have to have a written plan to address combustible dust risks with some type of a schedule. You need to plan, you may include studies. So again, you don't have to have it done, but what are we going to do to investigate this further so we come up with the best solutions for this plan? Implement, again, the implementation plan that you then show OSHA, they're going to hold you to it. So come up with a realistic plan that you're going to do. So implementation strategy. So what you want to do is you want to conduct an engineering investigation of your systems in high-risk areas to determine best options for safety compliance. You want to look at explosion relief pressure can be reduced, for instance, is one way with a combination of venting and suppression. So a lot of it is, you know what, we're never going to prevent metal from rubbing against metal if a bearing were to go on me. So I have to anticipate that there is a risk of an explosion, but how do I deal with it if I have an explosion to minimize the risk to employees and the business? A lot of it has to do with venting. A lot of it has to do with maintaining suppression, so you keep it in one place, and we're going to talk a little bit more about that as well for options. Again, you want to lower cost options, may include, as I mentioned, weak roof design. So you have explosion panels, for instance, in a roof. If you have an area where you've got a lot of dust or dust potential, and you're doing everything you can, but there's the risk is there. Again, if you can have blowout panels on your roof, and so the whole roof doesn't collapse in on itself, if you do have an explosion, that's one way of dealing with it. And again, a reduction in your dust concentration. So I mentioned over and over again, the first line of defense, sanitation maintenance. Sanitation audits should include potential threat areas. So as you're doing your sanitation inspection throughout your plant or on your master sanitation schedule, you want to be cognizant of, these are areas that can pose risk to us. We want to keep that. We want to keep our eyes on that. Cleaning schedules, again, to prevent accumulation. We hate getting up on ladders. We hate getting on the roof, on the ceilings, cleaning things off. We leave those maybe for a year, 2 years to clean, or worse. Those are the areas that are going to pose the greatest potential risk for you once that sugar, if it were to come off and become airborne. Preventative maintenance programs to stay on top of repairs. Can't stress that enough. How many times I've walked through plants and seeing residual dust, from leaking pipes, leaking equipment, rotary valves, things like that, where dust is leaking out. You need to replace a gasket, whatever. Stay on top of these things. Stay and make sure you service your dust collector systems. They don't do any good if you don't service them. So part of the program is monitoring systems. Again, if you have a situation where you're not going to prevent the inside of a bucket elevator if it goes off track on you and it starts to rub. So what do? You have monitoring systems that you can look at to give you an idea, kind of a pre-heads up of what might be going on. So determine possible ignition points, such as bearings, metal-to-metal contact, static electricity. For instance, on a bucket elevator, they have tracking devices. As I mentioned below there, implement monitoring devices such as available tracking. So if your belt starts to not track, it sends off an alarm, sends off a signal, kind of a precursor to, hey, if you don't do something about this, your bearings are starting to show a little extra heat than normal. It's all preventative. How do I jump on this before it becomes a major problem? So there again, NFPA 69 outlines many different options depending on the nature of the equipment, facility, quantities, types of dust. So as mentioned earlier, there's a lot of other solutions beyond your normal keep things clean, make sure you repair things. There are solutions such as there's chemical suppression. So if a system were to experience a combustible dust, what what do you have in place? It's basically like a giant fire extinguisher. So you may have an explosion contained in a vessel, but how do you prevent it from moving forward? How do you stop that fireball from moving on to the next step, to the next step, to the next step? You snuff it out there. Number of ways to do that. There is chemical suppression, as I mentioned, containment by design, explosion venting, flameless vents. You can do an inner atmosphere. Remember, one of the 5 legs of that pentagon is you have to have oxygen. There are people who are replacing, in situations where they have a nitrogen blanket rather than basically an air or an atmosphere blanket. So you're removing all of the oxygen and you're not going to have an explosion. You remove one of those legs. Again, you want to operate below those concentration levels if you can. Again, a lot of engineered solutions. So in addition to very easy ways to get started, looking at what you've got, you may be in a situation where you have to go further and implement some of these type of solutions. Again, explosion isolation is required to avoid secondary explosion. Like I mentioned, there are systems where if it senses an explosion, that pressure is monitored. It actually shuts down the input and output of a vessel, say, for instance, as you see here on the right-hand side. It prevents that fireball from moving forward and igniting further explosions. So both employer and employees have responsibility when it comes to this. So as an employer, you're required to perform a DHA, as I mentioned, and identify an implementation plan and have it ready to show an OSHA auditor, inspector by September 7, 2020. You've got to have that done. Again, you don't have to have the whole plan implemented, but you have to have a plan, and you have to show good faith that we're doing something about the risks that we've identified. So key areas for you to consider: look at your ingredients, look at your equipment, look at your processes, look at your building design. Excuse me, is there things you can do there? Again, as I mentioned, look at your maintenance and sanitation programs. What can you include there? And look at your employees' practices. How are they managing dust spills, residual dust, those type of things? What equipment are they using? What practices are they employing? Take a look at your process conditions. Look at waste control. Look at operation of processing equipment that might cause, through the process, buildup or residual dusts happening. It may not just be the raw material. It may be the product that you're making, but through all of the process you're running through a daily, weekly process, are you creating any dust out of the final product that you're making? So it's not just your raw materials. Again, recognizing possible combustible dust from packaging and processing of final products. Again, look at your building design, structures that support dust accumulation. This is the same slide I had before. Look at the ledges, equipment. How can you modify, if possible, any of these situations to prevent the accumulation of dust? Identify all ingredients, as we mentioned before, that could pose a threat for combustible dust, and take a look at each and every one of those items. What are their combustible dust components? What are the conditions whereby they can be subject to a combustible dust event? Again, look at equipment. We saw some of this equipment on the video I showed. You got screw conveyors. They're certainly contained. You've got augers or screw conveyors. You've got dust collectors. You've got bucket elevators, which is a fantastic place for problems to happen. Storage silos, those type of things. So again, from an employee side, it's really about awareness and training, right? So the employees have a responsibility for you to train them and for them to follow the training, cleaning practices, as I mentioned. Minimize the use of compressed air. I say, if you can, eliminate the use of compressed air to clean equipment of residual dust. You don't want to disperse that product. You don't want to blow that dust up onto higher areas, overheads, where at some point it can now become airborne at some point. Immediate cleanup of spillage of combustible dust and discarding them appropriately. Prohibit non-authorized equipment in combustible dust areas such as radios, electric vacuums, etc. I was shocked, and I learned something new. I had an OSHA inspector come into a facility that I was managing sugar, and we were filling tote bags full of sugar, and the employees like to have a radio out there out in the warehouse area, and I got cited. Cost me $5,000 because we had a radio out there, and the radio wasn't designed to be in a combustible dust area. And then not only would add insult to injury, so we eliminated the radio. 6 months later, OSHA came back in again, and unbeknownst to us, employees on second shift brought another radio back in. I got burned for $10,000 because of a repeat offense. So you really want to take a look at what's going on in these areas that you've identified that are combustible dust potential zones, and what type of equipment, what type of plugs are you using, what type of other types of electrical equipment that could supply that ignition source if they're not rated for that type of area. You forget OSHA. You want to protect your business. You want to protect your employees. But if OSHA catches you, it's going to be expensive. It's a tough lesson to learn. Learn from me if you can. I spent the money. You shouldn't have to. Again, report any dust leaks or accumulations to supervisors and maintenance employees. When you see things, you got to train your employees. Let us know if you find a leaking pipe in the silo room, and then jump on it. Because if you don't jump on it and take care of it, pretty soon they're going to say, well, they didn't care. I reported it, and that's not going anywhere. So you have an obligation as an employer. If you're going to train your employees to let you know about these things, you need to be jumping on it and taking care of it. So I want to close out that again. As I mentioned, we made this presentation at the American Bakers Association. We thought the information was so valuable that we know everybody at that conference was not able to make it to the presentation. So we wanted to be able to share that with everybody because it's very important. You know, employee safety and safety of the business is just at the top of my list. Just want to let you know that, again, they have this annual technical conference every year where people from the industry and from groups like ADS, so services industry, as well as equipment manufacturers, as well as bakeries themselves, they draw upon industry experts to bring different topics on the technical side. It's a very, very sharing organization. So their next one, they have, again, every year they have it in a different city. They typically have it in a city whereby they can end the conference by having a tour through some type of a food manufacturing bakery facility in that town. I don't know where they're going to have it in Kansas City, what bakery they're going to. This year it was in Atlanta. Next year they're going to have it in Kansas City. I would encourage everybody. It's well worth your while. It's about 3 days worth of different types of presentations. They have different presentations going on, so you get to choose one from another. Sometimes they do apply, sometimes they don't. They have wonderful full sessions and some interactive things that are going on too. So a great group to get associated with. So with that, I appreciate everybody's time today. I'm more than happy to answer any questions. I think, Courtney, you've got a method there for people, anybody would like to ask some questions, and I'm open for anything I can help you with.
Thank you, Ray. Yes, we do have a couple questions in already, but while we review those, if you think of any additional ones, just go ahead and use that question mark over on the left-hand side of your screen. Our first one is, who is allowed to perform a DHA?
Good question. So there is nobody has to be certified to do this, but basically you need to be able to demonstrate to OSHA when they come in and ask for your plan. If they cite you as, yes, you have combustible dust, risks here, you have to have someone with a reputation and the knowledge and experience to be able to conduct this. Typically, it's some type of an engineering person. A lot of companies have their own engineering staff, or maybe they have the maintenance group and an engineer on hand. They certainly could be done that way. There are engineering companies such as ADF Engineering. We actually have an engineer who specializes in this and has been going around the country for the last couple of years now, performing these hazard analyses for companies, and then also providing, not just giving you a report of where is your risk, but actually then being able to offer up the experience of how can we help you develop a plan for your implementation plan to resolve these issues. So ADF is one of those type of companies that can do that. It's something we offer. Again, engineering companies. So typically it's an engineering person that really understands the physics of the materials and the SDSs, as well as the processes themselves. Very good question.
Okay, and that leads us right into our second question, which is, does every DHA require an engineered solution?
No, not necessarily. As we mentioned that, again, not everything has to not everything requires a giant engineering solution. I can give you an example. I work with a sugar company, and they had 5 plants, and they were, again, sugar was really kind of under the microscope from OSHA, And last I heard, and this is after I've retired for 2 years now, but last I heard, they spent well over $300 million to bring their facilities up to speed. Now, that certainly isn't the case for many other facilities. Again, first steps, work with your employees. Make sure you clean up any spills immediately. Identify where your problem areas are. Go and fix all of your leaky pipes, your leaky valves, those type of things. Very, very cost-effective, non-engineering type solutions. Once you get that done, perform your DHA, and then, okay, what do I need to do next? If this were to happen, what's going to happen after that? That may require some engineering solutions, but not everything requires an engineering solution. Start small. Start with cleaning your facility up, addressing those obvious things first. That's a great place to start.